Awesome, great. So, welcome everyone to my YouTube channel. Um, so, today, March 12th, we'll be discussing some of the toughest problems that you can come across in SAT math section. Now, um, I have already solved them, and I'll just explain how you can solve these problems in the exam mode. Okay, so if you look at this very first problem, it says the graph of the linear equation passes through the points negative 21 comma negative 89 over 2 and 12 comma 65 over 2. The graph also passes through the point 27 over 4 comma a. Now we know that uh, we have a graph of a linear equation. So whenever we have a linear equation, that means we have a straight line, and for a straight line the slope is same. So if you have 3 points, the slope between these 2 points is gonna be same as the slope between these 2 points. So in this case, we have these 3 points and we don't know the value of this a. So what we'll be doing is we'll find the slope between these 2 points. Now the slope equation is m is equal to y2 minus y1 over x2 minus x1, and if you just set it up, we have this as y2 and this as y1. This is x2 and this is x1. So we have 65 over 2 minus negative 89 over 2. So if we subtract this turns into positive 77, and we can just go and check using DESMOS. We have 65 over 2 minus negative 89 over 2. So we have 77. And in the denominator, we have 12 minus negative 21. That gives us 33. So the slope is 77 over 33. Now, we know that it's going to be same slope for this point with either of these 2 points. So I'll just take this point and so I'll just take this point and this point. So we have 27 over 4 comma a, which is this point, and this is 12 comma 65 over 2. So if you just set up this slope equation, this is my y2 and this is my y1. This is my x2 and this is my x1. So 65 over 2 minus y1 is my variable a, and if we divide by x2 minus x1, we have 12 minus 27 over 4. So this slope should also be 77 over 33, which is same as this, because they would be same. Now we can just plug this in our DESMOS calculator. So in the numerator, we have 65 over 2 minus the variable a. In the denominator, we have 12 minus 27 over 4. And this should equal 77 over 33. Now, to have a value in the DESMOS, we just need to replace the variable with x or y. So I'll just put it as x. And you can see that the value is 20.25, which is same as 81 over 4. Which is 20.25. You can also write the answer in decimals. That should be fine. So this is our answer, 20.25. Or you can also write it in fraction, 81 over 4. Perfect. Now, let's look at this percentage problem. This is one of the common problems that you can come across in your SAT math section. So the problem statement says 360 is p% of 10. So anytime we have the word of after percentage, that means multiplication. So you need to keep that in mind. So now we can just set up the equation. 360 is means equal sign. P% means P over 100. Percent means over 100. So we set up the fraction P over 100 times this value 10. So now you can just plug this in our DESMOS. Again, we have 360 is means equal P over 100 times 10. Now to get the value from the DESMOS, we just need to change this with x or y. So I can see that my value is coming out to be 3600. So x is equal to 3600. That's my answer, which is p is equal to 3600. So 360 is 3600% of 10. That's my answer over here, and that's how you can solve it. Perfect. Now let's look at our third problem over here. The problem statement says the density of a certain type of wood is 770 kilograms per cubic meter. A sample of this type of wood is in the shape of a cube where each edge has a length of 0.7 meters. To the nearest whole number, what is the mass in kilograms of this sample? So anytime you come across the density problem, you need to understand this density formula. Density is equal to mass over volume. Okay, so mass is not given over here, so I'll just take this mass as my x variable. And for volume, we know that this is in the shape of a cube. So for cube, the shape of the cube has each length equivalent to each other. So we just cube that length of the edge. So it's side length cubed, and that's how we can get the volume of the cube. So in this case, the side length is 0.7 meters. So it's 0.7 cubed. And we can just plug this in our DESMOS. We have 770 is equal to mass over volume. Volume is 0.7 cubed. And we can see that if we just click on this x-axis, we can see that it's 264.11. So our x is 264.11. But the problem statement is talking about rounding to the nearest whole number, so it's coming out to be 264, and that's how you can find these volume. Sorry, that's how you can find this mass in kilograms of this sample. Perfect. Let's look at one more problem over here. Let's see. So let's talk about this problem. Take some time and see if you can solve it, and then we'll discuss this problem. So you have 3x squared plus bx minus 112 is equal to ax plus m times x minus l, given that a, m, and l are integers. So that's a valid point. That's a key point over here. A, m, and l are integers. Which of the following must be true? So we don't know about b, but we know that a, m, and l are integers. Which of the following must be true? So if you see here, this x has a coefficient of 1. So definitely I know that a is going to be 3. So if you just expand it, we have 3x squared plus bx minus 112. And if you just expand this right side, we have ax times x, which is x squared, minus ax times l, that should be alx, and this m times x plus mx minus m times l, that is ml. So this ml is equal to 112. So if you just make it equivalent, we can see that ml is going to be 112. A is equal to 3. And if we just factor this out, we can just write this as negative al plus m times x. So that should be equivalent to b. So negative al plus m is equivalent to b. Now, whenever we are trying to factor out any quadratics, we know that the middle term should be equivalent to these two terms. So if we add them, that should give us this middle term. Now let's try to compare each of these options. It says m is a factor of b. We don't see that. We can see that m is a factor of 112 because m times l is equal to 112. So m is equal to 112 divided by l, or we can find l is equal to 112 divided by m. We know that m and l are integers, so a is a factor of 112. We don't know that because 112. If we add for any for 3 to be a factor of any number, that number must be added to give a number which is divisible by 3. So if I add 1, 1, 2, that's 4. 4 is not divisible by 3. So 3 is not a factor of 112. A is a factor of b. I don't know b, so I cannot have this option. So if I just eliminate these 3 options, I am left out with option number D. And option number D makes sense because L is a factor of 112. We know that L is an integer, and by this equation I can see that m times L is equal to 112. M is also an integer, so 2 integers are multiplied to give 112. So m and L are both factors of 112. So this is our answer, option number D. Perfect. I hope that makes sense. If you have any questions, let me know in the comment. I'll be happy to check your comment and reply back. That's it for this live session for today. And we'll be having this live session every week. So please share this channel, put a like and comment, and spread this message to other students. In the meantime, if you have any questions, feel free to put it in the comment. Also, you can join my free school community where I have where I share more resources with the students. So the link is in the bio. You can just join it. It's completely free. There is absolutely no charge for students. Yeah, so I'll just wrap up for today, and I'll see you next week, same time, same channel, Wednesday at 12 p.m. Eastern Time. Take care. Have a great day. Bye.